And again, we test 0, 0 to see which side of the line it is. Is 0 plus 0 less than or equal to 120? The answer is yes. So then it is this side of the line. So this is labor and this is clay. But we don't want just one constraint. We want both constraints to be fulfilled. So it's obvious that our feasible region is this region right here. And by feasible region, we mean all points in this region satisfy both constraints. So any point in the feasible region satisfies all constraints. So any point in this region will be a solution to these two constraints. Now, thanks to a mathematician who came up with an algorithm to prove that we don't have to test all these points to find the best solution, the maximum solution. We just need to find the corner points and test the corner points and find which corner point gives me the best solution. And that's when your book starts looking at the optimal solution by sliding the objective function and seeing when it hits the maximum point. So we have these points, which let's call them P1, P2, P3, P4, and all you have to do is look at these points and calculate them and plug them in the objective function and find the ones that give you the maximum solution. So let's enumerate the points and find what they are. So we know that point 1 is the origin. Point 2 is 0, 20. Remember, this is BM. Point 3 is, I don't know, I have to calculate it. It's the intersection of both lines. Point 4 is 30, 0. So then we're calculating at each the objective function, 40B plus 50M. So that would be the total profit. But to start with, let's calculate the intersection points of both lines. This is two equations and two unknowns. So we come here, B plus 2M is equal to 40. 4B plus 3M is equal to 120. You have two ways to calculate two equations with two unknowns. One is substitution, the other is elimination. You can look up your notes from your freshman class or your high school class on how to do that, or you can Google if you forgot. Either way would work. Elimination is more general. What I mean by substitution, you can come here to the first equation. Anything that has a coefficient of 1 would be good. So if we do, let's say, substitution. By substitution, I mean you come to one that has a coefficient of 1. So B is 40 minus 2M. And so now I have B. I come and plug this B into equation 2. So now I have 4 times 40 minus 2M plus 3 times M is equal to 120. So what do I have now? I have an equation that's only in M. So I solve for M. I put all M's on one side and I put all the constants on another side. So if I calculate this, then you will find out that you could find that M is equal to 8. And then you come and calculate B. 40 minus 2 times 8, that's 16. B is equal to 24. That's one way, that's substitution. Elimination would be doing it by eliminating one variable. So you have to multiply one equation with, or maybe sometimes you have to multiply both equations with a number so you can eliminate one of the variables. So here the easiest would be to multiply the first equation by minus 4. Whatever you multiply on the left side, you have to multiply on the right side. And then you add them up. So if I multiply by minus 4 the top equation, and I add them up, minus 4b plus 4b will eliminate the b. So let's try that. Let's multiply by minus 4. That would give me minus 4b, minus 8m, minus 160. And let's carry the second equation as is. Now when I add them up, this eliminates it. This gives me minus 5m. This gives me minus 40. Again, m is 8, because you can divide both sides by minus 5. And that gives you b equals 24. Regardless which technique you use, you should get the same answers. So this, coming back here, this is 8, this is 24. And so now I'm ready to calculate the objective functions. 0, 0 will give you 0. 0, 20. 40 times 0 plus 50 times 20 is 1,000. This is my profit, total profit. If I make 0 balls, but I make 20 mugs. If I make, sorry, see, I made a mistake here. 20, this is, B is 24, M is 8. So this is 24 and this is 8. I apologize. So you have to be consistent when you carry it over. So 40 times 24 plus 8 times 50. So that's going to be 1360. So be careful when you carry over your point. And then 30 times 40 is 1200. You're trying to maximize profit. So out of all these points, which one gives you the maximum profits? Obviously, this point. This is the maximum profit. And so the maximum profit is 1360, and we get that by making obviously 24 balls and 8 mugs. No other combination will give us more profit than that. That's the production mix that will give us the absolute maximum profit. You can try any other point on in the feasible region or on the border of the feasible region. None of them will give you that kind of profit. Now, in terms of sensitivity analysis, again, it's hard to do sensitivity analysis with by hand manually. Because it's much easier to do it in Excel, but you need to understand it and what it means. But we'll do that in a different example.